Hello students, let us see this problem. This is a rather easy problem from not so easy book. So this problem is from Pathfinder. So the question says here that there is a fluid inside this tube, and the radius at this side is equal to R1 and the radius here is R2, right? And you have to determine the velocities of these two pistons when they actually become constant, right? So the question clearly mentions that you have to determine the velocities when they become constant. So what can we do about it? So first let's assume the velocities of the fluid that are just touching the this these pistons, right? So on the left hand side, on the larger piston, the fluid touching this larger piston, let's say, has velocity v1, and here this fluid has velocity v2. So this is going to be a streamline flow. Assuming a streamline flow, we can apply the equation of continuity. So from the equation of continuity, we get the relationship between v1 and v2 like that, right? What now? The question clearly mentions that the outside pressure is P1 and P2, not the fluid pressure. But it also says that these pistons are moving with constant velocity. So if they are moving with constant velocity, the net force upon them must be equal to 0, and that tells us that pressure inside this fluid just to the right of this left piston must be equal to P1. Otherwise, there will be net force on this piston, right? Similarly, we can say that pressure of the fluid just to the left of this right piston will also be equal to P2. So let's select these 2 points that are on the same horizontal line and apply the Bernoulli's principle, right? So applying Bernoulli's principle between these two red points here, we are getting this relationship, equation number 2, and using the equation number 1 and equation number 2, we can solve for values of v1 and v2. So that is our solution. Very straightforward and simple question.